recording and all that kind of stuff. You guys in that row, if it's in your way, or even this row, if it's in your way, you can slide around, you can move. If there's an empty desk, you want to sit in an empty desk, that's fine. I don't want that to obstruct your view. Alright, so let's take this out. And over here you see that it's saying the total G to K has to be 22, right? So we're going to commit that to memory. And I'm going to draw on top of these things. Now I know you guys can't do this in your homework, but what you can do is maybe visualize this each time in your homework. Maybe redraw it by hand, might make it a little bit easier. I'm going to have those three segments. The red one, the blue one, and the green one, right? Okay. Our goal, because they tell us G to K, they tell us the whole distance from G to K, right? Yes. So what we want to do is basically put our segments back to back, endpoint to endpoint, okay? Make them consecutive so that we can travel from G to K. All right. So what I'm going to do is I'm going to take this distance here, because that starts me at G, right? So I'm going to come down here. I'm just going to overlay it on top of that segment there. So that'll get me to J, correct? All right. Now I'm going to take the red segment. I'm going to pull that down here. And that will get me through K, right? But it gets me too far, right? Does everybody agree with that? Okay, I don't want to go past K. So here's the idea so far. What we've done, by putting those two segments together, algebraically that would be expressed as 2x plus 3, that was the blue segment, plus then 6x minus 2. And that gets me all the way down here past K. Well, now I need to backtrack a little bit, right? Okay. I want to go backwards, and how far do I need to go backwards? Yeah, I need to go x distance backwards, because that was kind of the overlap. Okay. Understand that this distance, x, is inside that segment there, which would have been the blue one, right? Okay. This distance, x, is also inside of the purple one. Okay, so that distance, x, maybe shows up right there. And, let's see here, it's maybe right there. Okay, overlapping the blue and the red. Okay, well, if I remove one of those, move backwards from this endpoint here, a distance of x, does that get me from G to K now? Does that visual help? Okay, so now I'm going to, when I remove x, what operation is that? Subtraction. So subtract x. Okay, now I've gone from G to J, J through K and a little bit further, but now I'm going to backtrack to K. So my total distance then, when I combine them like this, is going to be G to K. And they're telling me that should have been 22 is that total. Okay, the idea is, again, going back to the idea that those two initial longer segments, they overlap. Okay? Whenever you have overlap in segment addition, you need to get rid of that overlap somehow. Okay? And you got to determine how many times you got to get rid of it. For instance here, if I look at, let's just do it this way. Let's make that a little bit bigger. So that green segment, okay, is that overlap. Would you agree with that? Well, let's say I make that green segment white, and that should allow me to get rid of it. And now you see that if I take this 2x plus 3 minus the x and attach that to 6x minus 2, that will get me all the way from G to K, right? No overlap? Okay. So I got to remove that x. Okay. And when I do that here, it's either removing it from the red segment or it's removing it from the blue one. Make sure that you don't remove it from both. You don't want to remove it twice. Because if I remove it twice, what you really would be doing is something like that. And now you would put this segment here next to that segment, end to end, and that's not going to get you from G to K. Is that doable? Okay. So now solving that, how many x's do we have up there? Okay, careful. Yeah, 7. I'm sorry. I messed up. So 7x. So 8 minus 1 is 7. So 7x. And then you've got, what, plus 1? Equals 22. 7x equals 21. X is 3. Okay? Now the rest of the question, they're going to walk you through and ask you, okay, can you find what G to j was? Can you find what h to j was? Can you find h to k? That kind of stuff. Okay, but that's the approach that you want to use on that type of problem. All right. Very good question. Any others? Anybody want to talk about? Anybody struggle with that one? Okay, let's talk about that one. Okay. Every class has wanted to talk about this one. That's why I figured somebody maybe needed to. If we look at that one, okay, and I want to talk about these parts that they give me. They give me AD and AC. Okay. Before we do anything, what does that mark and that mark tell me? Anybody, just go ahead.
They're
anybody.
congruent.
They're congruent. Okay. So that tells me their distances are equal, right?
Yes.
What does that mark and that mark tell me? They're congruent. Okay. Now, because that one has 2 and that one has 1, is a green mark and a yellow mark, are they congruent?
No.
No, they're different. Okay. But what happens here, and this isn't really 100% necessary for this question, but we know that this segment here bisects AC, right? Bisect means cuts into 2 equal parts. And we also know that that segment there bisects EB because it cuts EB into 2 equal parts, right? So these two, it's kind of a rare situation. You don't really get 2 segments that bisect each other very often like this. But we want to look at the information they give us. They give us AD is 14. So I'm going to just highlight AD. So it's that green segment. And then I'm going to highlight AC, which is, we're going to do that in red. So AC is that segment. So we come down here and we get AC. Okay? So the reason I do that is just to help me visualize a comparison between these 2 things. Okay? Because a lot of times people throughout this course are going to want to say, well, these things, we want to make things equal. We've got to set up an equation. What's the root word of equation? Equal, right? Equate. Okay? We need to make things the same. We need to balance them. Okay? Right now, visually, those 2 segments are not equal, right? Okay? So if I just start setting things equal to one another, I've got a problem. I can't say 14 equals 2y minus 4. Okay? But because of those markings, because there's 2 hash marks in here, and there's 2 hash marks in here, do I know, oh, wrong color. Do I know that that distance from D to C is the same as the distance from A to D?
Mm-hmm.
Yeah, okay. So now would the green distance be equivalent to the red distance? Okay. But what did I have to do to the green distance to make them equal? I had to double them. Okay. So the green one was 14. You need to double that one. Okay. So I'm going to make this 28. Okay. So that's the green one. Okay. And then the red one is the 2y minus 4. Okay. We get 32 when we add 4 to both sides. Y then ends up being, what, 16? Okay. Once you have 16, they're going to ask you what is AC, so you just plug it in here. And then they ask you what is DC, so DC would be half of that. DC is going to be 14, right? Okay. What was I thinking? One second. Oh, another way of doing this. Okay. And I wouldn't necessarily always do this, but the only reason I want to bring this up is because of how the numbers they provide us kind of work here. We stretched that green segment, right? We doubled the green segment. Is there anything wrong with saying we can reduce the red one? Shrink the red one? How far do I have to shrink the red one so that it's equal to a green one? Half. Okay? So the red one is 2y minus 4. That's green. 2y minus 4. Okay, that's the red one. Let's reduce it by a half. Okay? And that should then equal my green one of 14. Okay? Now there's 2 approaches, and this is the thing about algebra that's really nice, but it's also the thing about algebra that's really bad, is that there's 2 or 3, 4 different ways I could solve that equation right now. Okay? Some people are saying, I'm going to multiply both sides by 2 to get rid of that fraction. Well, that's fine. Because if I do that, I get 2y minus 4 is equal to 28, which is exactly what we had prior, right? The first way we did it. Okay? So I would tell you that this is okay to do. But I see that both those numbers are even. And when I distribute that 2, doesn't that, or that 1/2, sorry, doesn't it make that really easy?
Yes.
Half of 2 is 1. Half of -4 is -2. Got my 14, add 2 to both sides, I get 16. Okay? But the only reason I talk about doing it that way is because I did recognize that that was a 2 and a 4, both even numbers. I got that factor of 1/2. If it was like 1/3 and 2y minus 4, I wouldn't do that. It makes things too nasty. If it's, 10y minus 7, not both even numbers, so I wouldn't do that approach. Okay? That's the one thing about algebra you guys got to realize is there's a lot of different ways of doing one thing, and based on how the numbers relate to one another, can kind of maybe direct you and say this is a good way of doing it, or maybe this way is a little bit more time consuming, maybe a little bit more difficult. Okay? Most people try to avoid what types of numbers normally? Fractions. Okay? So this allows us to kind of circumvent dealing with a lot of fractions. Okay? But hopefully we do enough in this class to where fractions are not all that terrible. Anything else you guys want to talk about? We do the clock problem?
No.
No.
I have no idea
Well,
what.
why didn't we say anything?
Because I
I
forgot.
forgot.
Okay.
Now until you said something, I didn't even think
I
about
have,
it.
Oh, I just
I have
got six.
things
It was
about
easy.
it.
So I did a similar
I mean, I
question.
understand
I
it
got 6.
'cause
I was like,
After
alright.
Mallory explained it, but when I was doing it, I had no clue what I was
I
doing.
tried to get Lindsay to explain it, and she had no idea what she was talking about.
360 degrees.
I had.
Okay, so 360. So what's the 360 thing? What's that telling you?
That's the
That's
sun
a
around
full
the
circle.
clock.
Okay, full circle all the way around.
But
So let
I
me.
had 4 o'clock, and I was like, what?
I
Okay,
tried.
so all of you had you all had really nice, easy numbers, like whole numbers, whole hours, right?
Yeah.
So you had like 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. You didn't have something like 9:15, right? If we had something like 9:15 or 8:37, the process becomes so much more difficult. I'll show you 1950 is not too bad, but 8:37 is time consuming. But you will, at some point, if you are going to go into like a trigonometry course or something like that, you will come back and talk about this type of problem and be able to say, okay, what's the angle regardless of the time? How would you do that? Okay. So the first thing I want to do is just set up our clock here. So somebody said around a circle is 360 degrees, right?
Yep.
Okay. So hopefully there's no debate in that. We all agree with that. I didn't want to do that. Sometimes these programs, because they're overlapping programs, they're not working together with one another. I always mess them up. There we go. That's what I wanted. Alright, so we got our 12 o'clock up top, right? Use this, that might be easier. So we're at 12 o'clock. You'll have 1 o'clock there. You'll have 2 o'clock there. 3 o'clock there, right? Let's just deal with that quadrant first. Okay, so let's say that I give you an angle that, let's say it's just 3 o'clock. So let me go in here, let's get, there's my minute hand, let's say that's my hour hand. Let's make them a little bit bigger so we can look at them a little bit easier. So those are my 2 hands on the clock, right? What's the angle between those? 90 degrees, right? Okay. So now here's my next question. How many minutes are there between 12 o'clock and 1 o'clock?
5.
How many minutes?
60.
60 minutes between 12 o'clock and 1 o'clock, right? Every hour has 60 minutes, correct? So if I have there, so if it's 12 o'clock on the dot, and then we go there, okay? Do it this way. Just think about just one ray, just the hour hand, or just the minute hand, doesn't matter. Let's just do the hour hand. If the hour hand changes from 12 to 1, it's gone to 60 minutes through, right? Okay. If the hour hand goes from 1 to 2, it's gone another 60 minutes, right? and from 2 to 3 it's going another 60 minutes. So what I'm trying to show you here or explain to you is that the interval between any 2 consecutive hours is still 60 minutes, right? Okay, which means that these spacings should be the same. When a hand goes from 12 to 1, it should be the same spacing as when the minute hand or the hour hand goes from 1 to 2, which means it's the same as it goes from 2 to 3. Is that doable for everybody? Okay, so that should be the same. Let me create another one here. That should be the same, that should be the same. So there we've got 1, 2, 3 angles that should be the same, right? You told me that when it was 3 o'clock you had 90 degrees here, correct? Well, if all 3 of those are the same, okay, if they're all 3 the same, and they total 90 degrees, what does each one have to be?
30 degrees.
30 degrees. So that tells us now we can expand that into the second quadrant, third quadrant, fourth quadrant, so forth. But that tells me between any 2 consecutive hours, there's a 30-degree angle, right? Okay. Another way of finding that is take 360, and basically if I put a bunch of these lines, these rays in here, you would have 12 sections, right? 360 divided by 12 gives me 30, just like 90 divided by 3 gives me 30. All right. So if they say it's 2 o'clock, okay, so you've got your hour hand on the 2 and your minute hand on the 12. How many of those angles are really in there? How many are those 30-degree angles? 2, so that would be 60, right? Now let's say that it was 5 o'clock. Okay, so the number of angles that you would have in there are 1, 2, 3 for your 90 degrees there, 4, and then 5, right? So 30 times 5 would be 150. So the angle from 5 o'clock to 12, okay, with those hour hands and minute hands would be 150 degrees. Is that doable? All right. So now here's the question. If it's not 5 o'clock, but it's 5:15. Actually, let's make it easy. Let's go 5:30. Let's say it's 5:30. Okay. If it's 5:30, no, let's not do 5:30. Let's do. All right, so that'd be 9, right? Let's do 9:30. So if it's 9:30, okay, is this hand really stuck at 9? No, because if it's 9:30, because we're at 9 right now, right? 10 is up here. Once it strikes 10, that hand's got to be on 10, right? So most clocks, this clock is kind of different. Like I think like every 2 or 3 minutes, that clock will jump, right? And it's not every minute it doesn't move, okay? So you don't see a clock very often say, okay, we're going to be stuck here at 9:30, and then when the minute hand goes all the way back up to 12, then it jumps to 10, right? It's progressive, and it starts to slide and move accordingly to where that minute hand is, right? So if it's 9:30, 30 is halfway between 60, right? 0 and 60. So this minute hand, or sorry, this hour hand, would be halfway in between 9 and 10, correct? Okay. So if 9 is here, 10 is there. Okay. Now, looking here, what would that angle right there be? At 9, if it's 9:30, that blue angle would be 90 degrees. Now this angle, okay, because that ray is moving towards 10, and if it's 9:30, it's halfway between 9 and 10, right? So how big would that angle right there be? Be 15 degrees, right? Okay. So now we're taking 90 plus 15, and we get 105. All right. So the 15, I guess the half-hour increments aren't too bad. Even the 15-minute increments aren't that bad. Okay. Because now instead of going 15 degrees, it'd be 7.5 degrees. Does that make sense? Okay. Well, if we've got 30 degrees was the degree measurement, right? If we go to 9:30, so 30 is half of 60, correct? So that's why we took 30 and divided it by 2, we got 15. Well, 15 is a quarter of 60, correct? Does that make sense? So a quarter of 30 times 1/4 gives me 7.5, okay? So that's why it'd be 7.5. So 15 minute increments is it something that's unrealistic and is it something you guys shouldn't be able to do? But like 1 minute increments, 2 minute increments, so if it was like 9:37, that is a little bit more time consuming, a little bit more involved problem. But it breaks down to the idea that there's 360 degrees in that thing, and every time the minute hand moves, it's moving 1/360th of that circle. Okay? And that's something like in a trig class, like I said, this question won't go away in regards to your high school. You'll see this in a year or 2 years from now, but we'll dive into it a little bit deeper. And that's usually what happens a lot of times, is that you start to get similar questions throughout high school.